Have already considered the first part of our course. It was devoted to the structural schemes, types of buildings. So also we have considered questions with multi-story building, with the rigidity, special stiffness, etc. Right now we will start the second model, which is devoted to the difficult ground conditions, and also it has some questions which are connected with the reconstruction. So first of all, we will start from the classification. So what is difficult ground conditions? We can consider as difficult ground conditions such territories like undermined areas, subsiding soils, water table uprising, flooding, casts, erosion, abrasion, squeeze, landslides, etc. Also, sites with the seismicity of more than 6 points are also also related to the difficult ground condition. When we will analyze the territory of our country, so we will see that more than 80% of the territory is devoted to the belongs to the difficult ground condition, and overall worldwide situation with the difficult ground conditions are almost the same like in Ukraine. So it is you as the future architect has a really high probability of working in the region with the difficult ground conditions. And sometimes we have a situation where we have a combo of difficult ground conditions. Right now, I have such a building which is located on the landslide territory and also has undermined territories both. And also, this territory is located in Odessa, which is high seismicity zone of Ukraine. So right now, I am working with the construction site, which includes a combo of three difficult ground conditions. So it's landslides, if it's undermined territories, and also earthquake hazardous territories. So that is why we have to consider this situation. You have to know what you have to know as a future architect what to do with your building when you are designing building on such situation. So first question that we will consider during this lecture is the undermined territories. So undermined area is the area which is under the influence of underground mine working. So uh, when we're talking about such situation, we have the underground mines which are made when diggers were um working on the uh, for example, limestone for the Odessa or coal mines or something like that, and underground emptiness, which can ruin during the vertical load from the outside. It can be can significantly influence on the building which is located above the undermined territories. So undermined territories are very important and dangerous. So that is why it is necessary for us to know what is the classification of the undermined territories. So it is the example of the Odessa undermined territories. By the way, Odessa, it's an Odessa called catacombs. They are like always filled with the water, so it's a combo of difficult ground condition, as I told previously. So, and the classification of undermined territories can be prepared by next five measures. So, subsidence, inclination, curvature, relative horizontal extension, and bench height. So sometimes it's not like curvature of a circle. It can look like a step or bench. So that is why we have to analyze these territories, the difficult ground condition, by comparing its effects on the surface. And here, how they can look like. So, and when we are talking about undermined territories, we have two kind of classification, four levels, which depends from the value of relative horizontal deformation, inclination, radius, curvature, etc. So, when we are considering this situation, in this case, the first category is the worst case scenario for the undermined territories, and the fourth is the better one. When we're talking about design of buildings on undermined territories, so we can consider rigid, ductile, or combined structural scheme for the building which is located above the undermined territory. So, for example, these kind of connections on the building which are located above the undermined territories is the example of creation of a rigid structural scheme. When we're talking about the combination of rigid and ductile, it can be considered in the next way. When we have two rigid buildings, for example, this is the part of one rigid building, this is the part of another rigid building, and uh, here is the ductile connection, which gives the ability when this support goes down or somewhere in the horizontal orientation, this slab will not fall down from this beam. So here's something more about subsiding soils. It's about the values of subsiding soils. So next difficult ground condition called subsiding soil. So when we're talking about the undermined territories, one more time, it can be classified by the values of steps or benches, or it can be classified on the other kind of effects on the surface of the earth. And when we are designing buildings on the undermined territories, we have to take them with rigid, ductile, or uh, combined structural scheme of the building. When we're talking about subsiding soils, it is another difficult ground conditions with which we are working like always, this, and this situation is caused by the combined impact of water and certain properties of the soil, because subsiding soils, it can lead to the deformations, something like that, and because of this building settles, or because the ground became wet under the influence of water, and that water uh, makes settlements, vertical settlements, which leads to the cracks or other kind of deformation in the structures of the in the constructions of the building. So that is why it is also important to make certain measures. And what can we do with the subsiding soil? So first of all, it's master plan solutions which give us an ability to not collect the water on subsiding soils, because if we will make this kind of orientation of L-shaped building, we will collect all the water right here. But if we will rotate this building, in that case, the water which goes from the from the upper points to the lower points will split in this way. So, and this will protect our building from collecting of the water in this corner. So it's a master plan solution. Other kind of measures are structural solutions. So, for example, if our building is located on subsiding soil, in that situation, first variant is to make the connection of this foundation with the unsubsiding soil. It may be using by using of piles, or it's may be made by substitution of the ground when we are digging out the old subsiding soil and substitute it with the normal load-bearing capacity, with the load-bearing capacity normal ground, for example, sand or something like that. Another one difficult ground condition called groundwater flooding, and this situation is really spread in Ukraine because the level of the underground waters is really high, and it leads to the to situation like this when we are constructing the building. And we have certain amount of measures what to do in such situation, and those measures are divided into preventive and protective. So first of all, preventive measures. So it is artificial increase of planning marks of the territorial surface. So to locate the foundation of our building as high as possible to protect it from the impact of the water. So next, it is compaction of the ground, ensuring of proper drainage of the surface water. So the water, so water not so make the impossible the collection of big amount of water in at sort of points of the building. Installation of waterproofing foundations, deep structures and communicate for deep structures and communication. Arrangement on anti-filtration screen, something like this, or construction of coastal men and other types of drainage. Next, protection of against flooding of cities and towns with groundwater. It is those protection measures can be split on two groups. It is arrangement of drainages of various types and performance on the external and internal waterproofing. So all the waterproofing can solve a big amount of problem. But when we are considering the combo of waterproofing with drainage, it is the best case scenario. It is the best solution to protect building from the groundwater flooding. And here is the example of radial drainage or line drainage near the buildings or in the middle of the buildings, so it makes possible to collect the water and protect the building from the water's impact on it. Next solution is to make various waterproofing and drainage solutions to protect our building from the outside water. Other kind of drainages also can solve this problem. So drainage systems are the best one of the best is one of the best solutions for the flooding surfaces. And how it can be done when we have a high level of underground waters. For example, we have all tubes, and the level of water it can be considered like this. So it's the level of groundwaters. But we can locate drainage tube, and this drainage tube can decrease the curvature of underground water pressure. For example, if we have like river or something like that located not far from the building, in that situation it will be difficult to pump all that amount of water, but it's also possible to make such solution to pump this water back to the lake or to the river. It will make possible to protect this building from this underground water level impact. And then sometimes we have find something curious and interesting like this situation. So this was the foundation which was digged for the it was made for the future building, but when the underground water arises, those waters make this foundation soak like a boat or on the water, and that impact of water from the it's Archimedes force make that building float like a boat. So next, kind of difficult ground condition called surface water flooding. And surface water flooding is really common near the rivers, lakes, and something like that. Sorry, I will make a pause. Sorry.